Okay, so what does a system of linear inequalities mean? Well, obviously, it has to have an inequality or linear inequality in it. So a system it is a collection or set of linear inequalities. For example, if I had y greater than or equal to 1, y greater than or equal to 2, y greater than or equal to 3, then all of them together is what we call a system of inequalities. It's a rather simple system, but it is a system of linear inequalities. So if you have one or more, more than one linear inequality put together as a collection, then we have a system of linear inequalities. As another example, I could have x plus 2y greater than or equal to 4 and x minus 5y less than or equal to 3. So just by themselves as individual inequalities, they are just a linear inequality. But if I put them together and look at them together, then that would form a system of linear inequalities. A key thing to note, to remark, a system of linear inequalities can have infinitely many solutions, and specifically in a graph, those infinite solutions are simply a shaded region that is common to all inequalities. Now, that is the most important word there, a shaded region that is common to all inequalities. If you want a different word, I could say the overlapping region. So the overlapping region among all the inequalities will be the solution. Now, it so happens that if we have a system of linear inequalities, that there may not be an overlap at all. So a very good example if I draw two parallel lines and we want to find a solution satisfying both inequalities, it would result in a problem. I would illustrate it on the side over here. So I'm going to consider a system, and the system would be y greater than or equal to 1. The other one would be y less than or equal to negative 1. Let's just say 0 is over there, 1 and negative 1. Greater than or equal to 1 would simply mean that line. We start with a line. And everything above. So I'll just go ahead and shade all of that. And the other line, I meant to write negative 1. It's negative 1, and it's a line that passes through negative 1. But in this case, the inequality is less than or equal to negative 1. So the shaded region would be all of that. And you can see that at the end of the day, there isn't a region that overlaps. In other words, we don't have a region that would satisfy both inequalities. So when we have the situation of no solution, that simply means no overlapping region. And it also means there isn't a solution satisfying every inequality in the system. So you may ask me, well, we have a system of linear inequalities. Should we follow the same process that we did with linear inequalities? Absolutely. Only the last time we had one single equation representing one line. Here, since we have two inequalities, two linear inequalities, we would simply have two lines, and that is it. So what would the corresponding equation be? For the first inequality, the corresponding equation is y equals x minus 3. So the slope of that equation is 1. The y-intercept is negative 3. The second equation would be negative x, negative 1. I like to preserve order. So the slope is negative 1, and the y-intercept is also negative 1. So now we just have two lines. Let's look at the first inequality. Should it be solid or dotted? It has to be solid because we see an equal sign there. So it has to be solid. And what about the second line? Well, that has to be solid also. One line at a time. So my first line, the y-intercept is at negative 3. The slope is 1. So it's right over there. You can pick a number that you like. And I'm going to draw a line through the points. And that's what I get. And it is best to shade it prior to drawing the next line. some may not have any difficulties, but it's good practice to shade and take care of the first inequality before starting the next one. So I'm going to shade, since it is greater than or equal to, I am going to shade all of that. And that is for the first inequality. The second inequality corresponds to the equation y equals minus x minus 1. The slope is -1 and the y-intercept is -1. So I'm going to use a different color. Blue might work. And since I'm going to draw a solid line, I'm just going to put a solid dot. And if x is -1, y would be 0. Now I have to draw a line through it. Okay. And now we look at the place where to shade. Now, since it is a greater than or equal to, we have to shade above the blue line. So going to shade everything above. Now there is a whole lot of shading going on here, but keep in mind, I can say that there can't be a solution right here. That is guaranteed. In this part, there is no solution, nothing shaded. But there is shading on other places. But when we have a system of inequalities, we have to look at the region that overlaps. And what does overlap? This is just an approximate sketch, so bear with me here. So all of that, including the line, and it'll keep on going. So that is the overlapping region. So that is what we call the solution set. Okay, so we have two inequalities, which would imply we have two equations. So the first equation is y equals 2x plus 4. So the slope is 2. The y-intercept is 4. And that is an increasing line, so it's going to go up. The next equation is -x, -5. The slope is -x. The y-intercept is -5. So we should take care of inequalities one at a time, and both of them are going to be solid lines because there is less than or equal to and greater than or equal to. So I'm just going to put solid dots. Looking at the first equation, the y-intercept is 4. And if I plug in 1, I'll get 6. So the line has to be, oops, that's not going to work. Let's try that. Good try. That. So that is the first line, y equals 2x plus 4. And now it is less than or equal to, so we have to have everything below the line. So shade everything below, and we've taken care of the first line. The next line is net y equals negative x negative 5. So the y-intercept is negative 5, and this is also a solid line. So I can put a solid dot, and the slope is negative 1. So we will have negative 4 there. And that would be our solid line. And the inequality states that the solution is everything above. So that would be the entire region. But the overlapping region should be our solution. So the overlapping region is right over here. And that would be our solution set. Okay. So here is another example where we have x greater than or equal to 3y and x plus 3y less than or equal to 6. The first thing to note is that it doesn't look like a line, but both of them are lines. So if x is greater than or equal to 3y, it is the same as saying 3y is less than or equal to x. Now, keep in mind, you may say, well, why should we write it this way? We're writing it this way so that we have the y's on the left-hand side. And if you're going to switch the terms around with equal signs, how the sign changes with inequalities, the inequality will flip. So you've got to be careful about that part right there. And the second equation, or inequality, I could write it as 3y less than or equal to 6 minus x. Divide by 3 on both sides. Y is less than or equal to 6 over 3 minus x over 3. Y is less than or equal to negative x over 3 plus 2. Going to go back to the first inequality and divide by 3 because I just need y on the left-hand side. So I had the original inequalities and I rewrote them as y less than or equal to x over 3 and y less than or equal to negative x over 3 plus 2. The corresponding equations are y equals x over 3 and y equals negative x over 3 plus 2. So that is the equation that corresponds to that inequality, which corresponds to that inequality. So that would be number 2, and that's number 2. So the slope of the first one is 1 over 3, and the y-intercept is 0. For the second equation, the slope is negative 1 over 3, and the y-intercept is 2. We'll start with the first line. Well, the y-intercept is 0, so that part's easy, and I have less than or equal to and greater than or equal to, so I'll just go with the solid line. And if I plug in 3, I'm going to get 1. So that would be my first line. It's close enough. And the inequality, you've got to be careful here. When we look at the inequality and when we shade, you should not look at the original one. That is incorrect. We rewrote it, and we rewrote it as y less than or equal to x over 3 because we wanted y on the left-hand side. So when you shade, you have to look at the one that you have rewritten and the one that is conventional to our graphing, which would require y to be on the left-hand side. So now we have y less than or equal to the line. So which would mean I'm going to shade all of that. And we can move on to the second line now. The intercept is 2. And it is a decreasing line. The slope is negative 1 over 3. So if I plug in 3, I would get 1. So they're actually intersecting right here. Okay, and the second line, we didn't flip signs at all. We just kept it as is. So, and the inequality is clearly less than or equal to, just right over there. So I can simply shade everything below. And the overlapping region would be the solution. So the most important thing to realize in this problem is that the flipping of signs and the inequality that we need to proceed with when we find the solution. So two inequalities. I'll number them so we can keep track of them. So 1 and 2. So inequality 1, negative 2x greater than y, but we want y to be on the left-hand side, which would mean y is less than negative 2x. That is the inequality we need to focus on. And the second inequality, I can rewrite it as 2y less than 3 minus x. Move x to the other side, it becomes minus x, which would mean 2y is less than minus x plus 3. Divide by 2 on both sides. 2y over 2 is y. Negative x over 2 is simply negative x over 2. And plus 3 over 2. Going back to the equation, we would have y equals negative 2x for the first inequality. So the slope is negative 2, y-intercept is 0. For the second equation, we have y equals negative x over 2. I could write it as negative 1/2 times x plus 3 over 2. So the slope is negative 1/2, and y-intercept is 3 over 2. So we will start with the first inequality. And when I mark the points, I'm going to be careful here because neither of them have an equal sign. So they are strictly greater than and strictly less than. So I'm going to start with open dots. So the y-intercept is 0 for the first one. So I'll just put an open dot there. The slope is negative 2. Which would mean the second would be there, second point. And clearly, this is a decreasing line. The slope is negative. The other one has an intercept of 3 over 2. May have to zoom this a bit. So 3 over 2 is right here. Oops. It's an open dot. And if we plug in 1, we will have 3/2 minus half. We will have 1. So that would be the next point. And again, that is dotted also. But before we do that, let's take care of the equations first. So, or the inequalities first. The first inequality states it's y less than negative 2x. So I'm going to erase this and come back to it. So I'm going to shade everything below. But nothing on that line, keep that in mind. We shouldn't include points on the line, the dotted line. That's what a dotted line means. But I'm trying really hard to get close to the line, but it's not necessary. This is for instructional purposes anyways. The next one, the slope is negative 1/2 and the intercept is 3 over 2. 3 over 2 is simply 1.5. So open dot there. And if I plug in x to be 2 or x to be 1 as well. And this is a dotted line, and it is a decreasing line as well. So and that's what we have. And the next one states the inequality is y less than everything that the line covers. The line's kind of slanted. Better, I guess. Yeah. That's better. Since it is less than negative x over 2 plus 3 over 2, we have to shade everything below that line. And that overlapping region that you see, the darker purple that you see, would be the solution to this inequality. So the key thing to note about an inequality is that they must have an overlapping region for us to have a solution. If we don't have an overlapping region, then we don't have a solution that satisfies every single inequality in the system.